In the previous video, we saw how to create a NOR gate. A NOR gate is nothing but OR gate combined with a NOT gate, and it is symbolically represented like this. Um, it's basically a OR gate, and this bubble indicates that outputs are inverted to form an OR gate. So we discussed this circuit, how to create a NOR gate using 2N3904 transistor. It's a NPN bijunction transistor, and through this, with this gate, I'm going to show how we could create a binary adder, and then how I will also demonstrate that using a circuit that I have here. So this is the circuit diagram, the logic circuit diagram to create a full adder, and what we have here are 9 NOR gates, and we know that we can build these NOR gates using one transistor. So we are going to use 9 transistors to build this full NOR gate that will take two inputs, A and B, and then it can provide the sum out and then a carry out. And I will also try to simulate on an app how the inputs try to switch on each of these gates and how the output works. And let me go into the circuit here. So what I have done here is I have connected the transistors, and they form NOR gates. There are 9 NOR gates in here, and this dip switch will be used as input A, B, and C, that is carry in, and these two LEDs will do the red LED will be used as the sum out, and the green one will be working as the carry out. And the circuit is powered up, and I have this truth table in front of me. This is a simple truth table for 1 plus 1 bit adder, and let's try this on this circuit, and let's see if it works. The first one that we see on the truth table is all zeros. When all switches are off, the output on sum and carry out should be off, and that is what is happening right now. When I try to switch on either carry or B or A, in these three logics I should get one output on the sum, these three logics. Let me try that. So when I switch on A input, I get output. When I switch on B switch, again I get output, and when I turn on the C carry in, again I get output, the sum out. Okay, so we can say that we tried this one, it worked, this logic worked, this one worked, and this one worked as well. Now the next one that we need to try is when B and C are turned on, the carry should be on, or A and B turned on, the carry should be on, or A and B, any of the two switches on, then the carry should be on. Let's try that. I'll first try with A and B. We see that the carry is powered on. Now I'll go with A and C. Now again we see carry coming out, the power on. Now what I will do is I will do with same with B. B and A, the carry comes. The switch is not so good. Okay, now B and C, the carry turns on. I think we simulated all possible combinations. And the last one to try is when all three switches are on, then we should get sum and carry out. I'll try that as well. Okay, when A, B, and carry are input on, we get sum output as well as carry on. So that is a simple way of building a full adder. And the idea is we can have multiple circuits like this, and then we can get the carry out as an input to the next circuit carry in, and we can form circuits like this in multiple um, circuits like this, and then we can start adding more number of bits. So from 2 bits we can go up to 4, 8, 16, 32 and 64. Our modern day computers work with 64 bits. Now this is the simple logic how your CPU adds numbers, and then the output is converted into a decimal format, and that is what we see in our monitor. Now I will show you a small simulation. This is through an app that I downloaded, and in this app I used again 9 NOR gates, logic gates, and then using this I'm going to demonstrate how the circuits get powered on, how the current flows, which gates turn on and which gates turn off, and then how do we get the power out. Now you can see that these three are the switches, these two are the LED outputs, and rest of them are all NOR gates. I'm going to consider this as the A input. When A input is turned on, you can see how the power flows and which gates turn on and off, and how do we get the power out. I'll go with B and carry in. Now I will turn on A and B. Now we get the carry out, and you can see which gates turn on. A and C, carry on. Now do the same with B and C and get the carry on. And when I turn on all three, I get sum as well as carry out. Now you can see which gates turn on by looking at these green and white colored wires and the gate outputs. So this is a simple example of how logic gates can be built using a single transistor, and using those simple logic gates how we can add numbers in binary. And in the next upcoming videos I'll show how to convert this binary into a decimal, and this is the basic fundamentals of how digital computers work. Thank you.